Good morning, AP Calculus AB students. It's Wednesday, March 18th, and this is Miss G. I hope you had a great day yesterday. I hope you caught the rainbow. That was a nice start to yesterday. A little early, though, maybe around 7:30. Anyway, I hope you're ready for today. I had a few questions that were homework requests. Page 366. Numbers 5, 9, and 13 were the requests, so I'm going to go through a couple of them. If you already get all these, you could probably fast forward to my little section of notes. I don't have too many notes today. But anyway, here we go. This is number 5. It was to solve the differential equation y prime equals 5x over y. So first I rewrote y prime as dy dx, and then multiplied by dx. Now we have a y on the dx side, and we don't want that. We want the y on the dy side. So we multiply both sides by y, and here we go. We get y dy equals 5x dx. Now we've separated the variables. So now we just integrate the left and integrate the right. We integrate the left with respect to y, we get 1/2 y squared. The right with respect to x, 5/2 x squared, and there is our plus c. But the object is to isolate y, and we have this 1/2 over here. So we're going to multiply both sides by 2, which gives us y squared, gives us 5x squared, and really does give us 2 times c. But again, 2 times c would just result in another constant. So we're just going to call it c. I guess I could have called this one c sub 1 and this one c sub 2, but in the final analysis, it's all a constant. Now, if you are, this is okay, I think this is the answer in the back of the book. But if you really wanted to isolate y, you could take the square root and in fact put a plus or minus in front of the square root. When you're imposing a radical that isn't there to begin with in the problem, you need the plus or minus in front. And then depending on what point you're looking at, because they might give you a point to find c, that would determine whether you use the positive square root or the negative square root. But in this problem, we don't quite have to deal with that. Okay, I'm going to jump to number 13 and then go back to number 9. But 13 said, the rate of change of n with respect to s is proportional to 250 minus s. So we know from yesterday that proportional without the adjective in front of it is directly proportional. So we write that rate of change. That's our derivative of what? Of n. So that's dn with respect to s. ds. dn ds is proportional, is equal to k times the quantity 250 minus s. So again, we have variables n and s. K is a numerical value, but n and s are the variables. So we multiply by ds. And then we're going to integrate both sides. Now your book or Calc Chat does this a little differently. So I'm going to do it, take 2 approaches. I'll do the first one that I think they did in the book. Integrate the left, integrate the right. K is a numerical coefficient here to this expression, so we can pull it in front of the integral sign and just integrate 250 minus s ds. So what they did was, they used a u to u substitution on this. I know it doesn't really look like one, but they took u and made it 250 minus s, and then du would be negative 1 from the negative s. Negative 1, derivative of negative s would be negative 1 ds. So let's go back and look. We pick up a negative here that's not in the original problem. So we take the reciprocal of it or compensate for it by putting a negative in front of k. And now we're integrating u du, which we all know is 1/2 u squared, plus c, and we have our negative k here. Now we take the u and plug back in the 250 minus s. So what we're looking at is negative k times the quantity 1/2, which is being multiplied by the quantity 250 minus s squared, plus c. And if I simplify it a little bit more, I get n equals negative k over 2 times the quantity 250 minus s quantity squared plus c. Okay, now we're going to come back to this because I have a feeling that some of you might have distributed this k in the beginning and got 250k minus ks. And we could do the problem that way as well. So I'm going to do it that way, and then we're going to compare the two answers and see how they differ. All right, So here is the problem again. We're going to distribute the k this time, and we're going to multiply by our ds, and now we're going to integrate both sides. So what we have here is 250k minus ks that we're integrating. And if you integrate 250k with respect to s, you get 250ks, because 250k represents a number. Ooh, almost forgot. If you integrate 1 dn, you get n. All right, so our 250k integral of that turned out to be 250k s. Our variable is s. Minus the integral of s with respect to s is really 1/2 s squared. But we have this k, and 1/2 times k would be k over 2 s squared plus c. All right, so that's a good answer too. If you got that answer, I'm happy. Okay, let's compare that answer with the one we got in the other method, which was down here, but I rewrote it up here. If we FOIL this out or multiply this 250 minus s quantity squared from the other answer, we would get our negative k over 2 from the other answer, 62,500 minus 500s plus s squared if you FOIL this out. And if we distributed the negative k over 2 times 62,500, we would get negative 31,250k, negative k over 2 times negative 500s plus 250ks minus k over 2 times s squared, which would be minus k over 2 s squared plus c. It looks a little different from this answer here. Let's compare. Well, we both have plus c. We have negative k s squared, negative k over 2 s squared, negative k over 2 s squared. We have positive 250ks. We have positive 250ks. So really the only difference is this negative 31,250k. But guess what? That represents a number. And guess what C represents? A number. So we can consider that these are equivalent in that if we take the negative 31,250k added into the C, we would get the same answer here. Okay, just wanted you to see that. Okay, next problem. I saved it because it's a long one and it takes up my whole page. So this was number 9. If you got it, you can move on a little bit and get the notes. If you didn't get it, here we go. So we have 1 plus x squared times y prime minus 2xy equals 0. I rewrite the y prime as dy dx. What did I do first? Let's see. I added the 2xy to the other side. I'm trying to isolate the dy dx. That's what I'm trying to do right now. So I added the 2xy, and then I'm going to divide by the 1 plus x squared. Then I'm going to multiply, as I always do, by my dx. The problem is, on this side I have x's, but I also have this y. It needs to be on this side with the dy. So I divide by y, and I get 1 over y dy equals 2x over 1 plus x squared dx. And you've separated the variables. And remember, that's usually worth at least 1 point on the AP test, that if you separate the variables in a differential equation. All right, now what? We need, let's see, what did I do first? I guess I left this integral alone, and I did a u/du substitution on this. So u is 1 plus x squared, du is 2x dx. Now that gives me, which is nice because the 2x dx is the rest of the problem. The numerator and the dx is covered in du, and the 1 plus x squared is covered by the 1 plus x squared substitution. So this representation is the same as 1 over u if we use these substitutions. So 1 over u du, I have to say du there, because the du is actually part of the problem. All right, now we're integrate the left and integrate the right. Integral 1 over y, ln absolute value of y. Integral 1 over u, ln absolute value of u plus c. And then what? Well, we put the x's back in. 1 plus x squared. And oops, I almost put absolute values, but I don't really need them because 1 plus x squared is always a positive quantity no matter what x value is. Now we exponentiate both sides, and we end up with y equals e to the exponent, which is ln the quantity 1 plus x squared plus c. That's the whole exponent. As yesterday, we take the exponent apart and we make this y equals e to the ln of 1 plus x squared times e to the c. e to the c becomes the capital C constant, and e to the ln of 1 plus x squared from your pre-calc is just 1 plus x squared. So the final answer is y equals c times the quantity 1 plus x squared. I hope some of you got that out there. I'll be really happy if you did. And I'll be happy if you understood this. So there we go. Let's see, what are the notes? Our notes are a little bit short today. I hope tonight's assignment's easy for you. This is more differential equations. It's section 5-7, same concept, separation of variables. But tonight, you're going to verify solutions. You might find it a little easier. You're going to determine whether the given function is a solution of the differential equation. So here's the differential equation. And sometimes we can't integrate it to get back to the original. But we can propose a solution, or actually the book will propose a solution, and you just have to figure out if it works in this differential equation. And remember, it's a differential equation because it has derivatives in it. A derivative, second derivative right there. So what we need is to find the second derivative of the proposed solution, substitute it in for y double prime, subtract y, which is the actual original problem, and see if we get 0. So the first derivative is the derivative of 4e to the negative x is 4e to the negative x times the derivative of negative x, which is negative 1 by chain rule. Simplified, it's negative 4e to the negative x. But we don't have a y prime here. We need a y double prime. So the derivative of y prime is y double prime. And if we take the derivative of y prime, the derivative of negative 4e to the negative x, negative 4 is a coefficient, you can pull it aside. Derivative of e to the negative x is e to the negative x times the derivative of negative x, which again is negative 1. So we have negative 1 times negative 4 is positive 4e to the negative x. Now we have what we need to determine if this is a true statement using y equals 4e to the negative x as a solution. So we verify, just recopied that original problem, well, this original differential equation, and the proposed solution and its derivatives. So y double prime is 4e to the negative x. That goes in for y double prime. Minus y. Y is the statement of the original problem. 4e to the negative x. Then I work it out. 4e to the negative x minus 4e to the negative x. Does that equal 0? Yes. 0 equals 0. Voila. It's true. Yay, so those are the notes for today. Your assignment includes a couple of these verify problems and a couple more differential equations like last night to solve with separation of variables. So this is the assignment right here. Don't forget to check answers in the back of the book or check Calc Chat and email me if you have any questions, you want more explanations, or you want me to do the problem out. And I hope you have a great night. Okay,